During a mountain building event called an orogeny, uplift, weathering, and erosion of pre-existing rocks often create an erosional surface called an unconformity in the rock record. In Georgia, the Marble Hill Hornblende Schist of the Mineral Bluff Group lies on top of the Murphy Marble of the Hiwassee River Group, which is immediately above a significant unconformity. This important unconformity between units is interpreted as marking the onset of orogeny in the southern Appalachians. However, different geologists assign this unconformity to different orogenic events because the age of the overlying mineral bluff group is poorly constrained.
If we are able to extract datable minerals from the Marble Hill Hornblende schist, it would allow for a definite age determination for the mineral bluff group and determine which time period the unconformity is associated with. One of the best ways for us to determine a reasonable date on the Marble Hill Hornblende schist was to work on pulling the zircons out of the rock. Mineral separation itself is already tedious work, but to separate rock that is mafic in nature is something that is not often heard of. Zircon, which is the chemical formula ZrSiO4, is used for radiometric dating due to the fact that zircon can normally house uranium.
This presence allows for the determination of the crystallization age of minerals in the original magma chamber. Mafic magma chambers do not normally have the silica needed to form the zircons because the chamber is pulling other elements to create mafic minerals. This leaves the magma chamber poor in silica or silicon and oxygen, which is a critical factor in growing zircons. Some zircon is difficult to find in rocks like the Marble Hill Hornblende schist, so many geochronologists are often reluctant to attempt to separate zircon from the primary mineral phases.
Dr. Barano presented us with a rock that he had collected east of Tate, Georgia. He started by showing us how to use the rock crusher. The rock crusher pulverized our rock, which allowed us to sieve it. Zircons are less than 300 microns, so we are able to use a sieve that would filter out all of the rock sediment that was greater than 300 microns. It took lots of trial and error for us to figure out the best way to get the shake table to separate our sediment. We finally landed on putting our sediment mixed with water and a little bit of dishwasher surfactant to drip on the table at a steady rate. This was the best method to get everything separated into lights, mediums, and heavy areas on our table. Zircons are fairly dense, so we knew to start looking in the heavy sediments that were separated.
After processing approximately 800 milliliters of the Marble Hill Hornblende schist through the shake table, we were able to gather 75 milliliters of heavy mineral fractions to process through the France isodynamic magnetic separator. We first did this with a large Cal magnet, taking out all of the super susceptible magnetic grains, and then moving on to multiple rounds in the France. Once we processed the heavy fractions through the France, we were able to gather 2 test tubes potentially filled with zircon, bedyllite, and quartz crystals.
Our final step was to learn how to use the heavy liquid separation. When our 2 test tubes were poured into our heavy liquid, our really dense mineral grains, like zircon, sank to the bottom. Once all of the dense minerals were taken out of the methylene iodide, we had separated the mineral grains to the best of our ability, and it was time for us to begin the hunt for zircons under the microscope. Our potential zircons that we recovered were mounted for chemical analysis in our scanning electron microscope.
The highest density mineral grains from our heavy liquid separation produced approximately 50 zircon crystals that were picked apart over the summer. Recovered zircon will eventually be sent off to a geochemistry lab capable of performing isotopic analysis of the separated grains. This will allow us to determine the crystallization age of the igneous protolith of the Marble Hill Hornblende schist.